Hey guys, I thought I'd do a little extra video today detailing the ins and outs of the divide length C# script that we used in the previous video. So this will be a bit of a code along exercise, but you're not going to be tested on any of this kind of content. It's more just for your own understanding of how something like this gets made. And so hopefully you can make your own one day. So let's just bring a curve in and let's just drop a slider down. So this will be the curve that we want to divide by lengths of 51 units, I think millimeters in this instance. So let's drop a C# component down. And then what I'm going to do is rename X to curve. And I'm also going to call it, specify the type hint of curve. And I'm going to call Y seg length, so segment length. That's going to say is an item access, and it's going to be a double. So double means is another term for floating point number. While our number slider isn't a floating point number right now, let's make it one just to show that it works. Okay, and then maybe we'll hook up a panel just in case we get any bugs that we need to work out. Okay, so let's open up the hood. And you'll see up here that we have a curve called curve coming in, which is here. And we've got a double that's called seg length coming in here, and then out having an object coming out called A. That's great. So what we want to do first is the way that sort of scripting works is it is a complete open sandbox. You can make whatever you want. However, in Grasshopper we might just go divide curve and chuck that curve in, and away we go. If you're scripting something, you've got to make all the steps from scratch. So what we need to do is first, why don't we'll make the list of points coming out. List to contain out points. I'm not going to dwell too much on the syntax of C#. I'm just going to show you that this is how you create a list. Equivalence equals new list. Cool. Oh, better. Awesome. And then let's get the length of the curve. The length of the curve is probably going to be a floating point number or a double. I'm going to call it curve length. I'm going to run, what do I want? Get curve length. Get length. Cool. That seems to be alright. So the way that what happens now is, I've gotten the length, and then I'm going to go, alright, the curve length divided by 51, and that's going to be most probably, it's going to be a floating point number, not a whole number. If it was a whole number, it would mean that it would go evenly into it. So if the curve was 10 mil long and I was having 1 millimeter long segments, we'd get 10 divided by 1 is 10. If our segments were 1.33, we'd get a little left over. So what I want to do is do a compute a division that gives us the floor value. So instead of getting 1.2, we'll just get the 1. So the way I'll do that is double floor division equals math dot floor curve length divided by seg length. Oh, what have I done here? That should be okay. And then create a floor integer called floor integer, which is equal to. So what I'm doing now is 32. What I've done now is I've spelled floor wrong, but I've done the floor division, and that's given me back a floating point number that is equal to a whole number. But I need to convert that floating point number, which is also a whole number, into an integer. And this command, this method convert to integer. 32 just handles that for me. So with that, I can start to compute the curve parameters. And that is going to be, they're going to come out as doubles. So they're always going to be, generally from 0 to 1, 0 being the start of the curve, 1 being the end of the curve. So it's going to come out as a list called curve parameters equals curve dot divide by count. So there's already a method there for that. And it's going to be floor integer, and it's going to be true. So long story short, we need a curve that we're dividing by, of course, which is CRV curve. We need a 32 integer segment count, which is our floor division, and we need a boolean to include whether we take the ends or not. And we do want points on the ends in this instance. So we've got that done, and then so that should return us back the actual divisions. Let's just have a look at that. Let's see if that's worked. What do we call that? Curve parameters maybe, and we'll have a test. Oh, forgot the semicolon. You do that a lot. Yep, so that's giving us some parameters, but they're whole lengths, which should still work. We'll have a look anyway, how it goes. What do I have to do now? Oh yeah, that's right. You have to perform the actual curve division. Well, curve division now. Curve division. So we're going to do this we're going to iterate over our curve parameters, and for each curve parameter we have in this list, we're going to put a point on this curve at the length. So what are we going to do? For int I equals 0 to I who is less than curve params dot length, so the length of the curve parameters list. I plus us, let's keep incrementing. Cool. And inside there, all we're going to do is go curve points dot add curve dot point at curve params at the ith one, and then we need to close that off with that many brackets. I'm pretty sure. And if so, we go a equal to curve points, and there we go. There's our points created that are 51 mil long. Although they're not going to be 51 mil long, they're actually going to be a bit wider or a bit larger, a bit smaller. So why don't we, in my other component I had the adjusted difference here, which might be useful sometimes, and just as a good indicator to have as well. So why don't we go? Let's just first label this outputs. Cool, and we'll go UI display. So what I need to do is grab, each of these segments are going to be the same length. So I'm going to grab the first length segment. So interval curve interval equals new interval curve params. Okay, I'm going to grab the second, the third or fourth one actually, which is 2 and 3. Like so. We could do the. I don't know why in my notes I had 2 and 3. I think I was just testing it. Cool. And then what we're going to do is we're going to measure the length between this parameter and this parameter. So double just integer. Let's curve dot get length curve interval. Let's just get some spelling there. Then what I'm going to do is component dot message equals altered length int dot to string. And there we go. So I start off as 51, but the alter length is actually 51.94, like that large number. And why don't we actually as well, like you might need that length later on. So let's spit that out as B now. And there you go. So something that's like, I made it because it's useful to me, and I was sick of using the paneling tools one. But again, like there's a lot to digest there, and like I'm not here to teach you C#. I'm just showing this, giving you as many like code-along exercises that show how stuff is made in Grasshopper, so you can start to learn from just like copy pasting things here and there. Like you might find that this component.message is really useful and want to use that for all certain kinds of things. Or you might find that this is a really dumb way to do this task, and there's a whole bunch of others. The way that David Rutten coded his version is probably a bit different, but this is how I did it, and it seems to work for me. So on that, I'll leave it here. Thanks for watching, guys.